You're welcome.
My name is Andreas Humpe, and I wrote this paper together with my colleagues Holger Günstl and Lars Brehm. We are all from the University of Applied Sciences here in Munich, and the title is Jumpstart into Artificial Intelligence for Engineers on the way to become virtual. Okay. So basically, the idea is, I mean, there are two things. The one thing is we want to teach our students basic knowledge in artificial intelligence, which is to a certain extent challenging because things can become very, very complicated. And as we have heard before, it involves usually a lot of statistics and a lot of coding. On the other hand, obviously, they should get a good and decent knowledge of the subject. So in the beginning, very often it's a challenge to motivate them, because if you start with the coding or with coding too much, then it's probably too difficult for some of the students, and it becomes more difficult to keep them motivated. So the idea is to have a workshop to start with, where students can do something practical within a fairly short period of time and see what they can do with artificial intelligence, being more motivated. And then later in the lectures, obviously we have to do more coding, more statistics as well. So basically, it can be very complicated. There are a lot of applications that are too simple, so we had to find somehow a middle to teach them something interesting, but it's should also be on a higher level so that they really know something afterwards. This learning lab, as we call it, Jumpstart into Artificial Intelligence, is basically a one-day workshop. So we do this within one day. It should just provide a first understanding of the technical aspects as well as applications of artificial intelligence. It should primarily aim to raise the interest in the topic so that people are very motivated for the class afterwards, and just show some simple applications they can do very easily. So we start by a classification of the topic so that people really understand what we are talking about. Then we are using TensorFlow to do a pattern recognition exercise. It's very much a hands-on approach. People have the opportunity to work with data and statistical methods hands-on. And finally, we also discuss some ethical questions that should generally be addressed when we are using artificial intelligence. This is one thing, so teaching them artificial intelligence, the basics. The second thing is, due to this pandemic situation, we had to teach it online. So it used to be a classroom workshop. We could do it in class. However, over the last 1.5 years, I would say, we had to do it online. And it was very challenging to transform this hands-on workshop to an online format, because when people are working in groups, it's becoming much more difficult to do it online, basically. The overall workshop and also the assessment we wanted to do is based on constructivism, which has different dimensions. I just show those dimensions and what it really means for the workshop here. First of all, we have an active dimension. So to activate people to be active, basically they have to work very autonomously. They can use this online environment, and they have certain kind of objectives they have to achieve, but by and large they're quite free, and they have to do very active to complete this workshop. Then the second dimension is the constructive one. Well, what does mean constructive? It's important that they can build on existing knowledge, which is again a problem, because usually students have different standards. Some people know parts of what they're going to do, others don't. So we have to start with an introductory lecture just to make sure all students are on the same level and they can build on existing knowledge so that they're not getting lost during the workshop. Then we have an emotional dimension. So we all know if there are emotions involved, usually people are better and are more motivated, and also the learning success is higher by and large. One way of making sure people do not have negative stress, we decided not to give any kind of marks for the workshop, so they won't be marked afterwards. And we have like a lot of like smaller tasks they can do within a certain kind of time frame fairly easily if they work on that constructively together. And so they have a feeling of success, which is rising motivation and good feelings. Then it's very much self-directed. They have no set timetable. They can work independently in those teams together. Then there should be a strong social factor. Well, as I said before, if you're working in class, it's quite easy because they work in a small group in a classroom together. When it's done online, it's getting a bit more difficult, but by and large, this worked out fairly well as well. And finally, the situational dimension that is important here as well. So it should be something realistic, something useful, so they have the feeling they learn something they can use in life, which we also try to implement in the workshop. So basically, we had fairly small student teams, like 2 to 3 people that were working together in breakout rooms. So we were using, for instance, Zoom, where we have those breakout rooms. Students are collected to a group where they have to do this workshop together and solve all the tasks they have to. It's more or less guided self-learning by students, meaning you have assignment sheets where they have the tasks they have to do. They get some certain kind of background. So they have to do a lot of background search themselves. They get like information on certain kind of internet links where they could look up and find new information. And after each of those assignments, we have a reflection session where all students come together and discuss what they have found, what problems they had, what ideas they found, and so on and so forth. The lecturer is more or less only a coach. So they work together in this group. We try to pop in once in a while to these breakout rooms and ask them whether they have any questions, but we're not guiding them. We're just asking them whether there are some problems where we should give them a feedback. So we are just a coach. And the set of assignments is fixed. So usually they start with fairly easy assignments. The further they get, the more complex the tasks are, the more complex the assignments are. And they really have to work very, very interactive. They really have to experience the learning part. It's not just slides they're looking at. They really have to do something hands-on. They really have to come up with solution to the problems they find in those assignments. Here are the 5 assignments they have to solve. First of all, it's basically introduction, where they have several projects that are supported by artificial intelligence from different areas, from society, economy, also from astrophysics. So very different areas where you can use artificial intelligence, and it's mainly finding out about those projects, what kind of algorithms are used, what are the results, what can be done here with artificial intelligence. Then they have the first, in the second assignment, they have the first online experiments they are doing. They are using Google, where they can have different RE algorithms that are used, data science, and so on and so forth. So it already starts that they can do something hands-on here. And then they move to the next assignment where they have those Google Quick Draw. I don't know if anyone has used that before. So you start drawing on a pad, and Google tells you within a fairly short period of time what you're actually drawing. Sometimes very surprising, because you just start drawing whatever bicycle, and once you have started with the wheel, it already tells you it's a bicycle. And it's interesting to see. However, they also have to figure out how it works, how artificial intelligence can do that, what kind of algorithms are used in the background to do that. And then we really start giving them an own project, which is a learning project with an RE algorithm, again using a Google Teachable Machine. And in that case, what we have is we have satellite data. And the satellite data shows in some cases moors, and moors can be very helpful because they can store a lot of CO2. However, in order to store CO2, those moors have to have a certain kind of water level. If there is too much water, it's not good. If there is not enough water, it will actually even release CO2 emissions. So it has to be made sure that it is a good moor that is really able to store the CO2. And you can teach basically this algorithm that it can understand whether this moor is in good shape or not. So we could intervene and could say we need more or less water in order to make it a good storage of CO2 again. And students have basically images with moors that are doing fine and others that are not. And so you get a classification algorithm telling you whether this moor needs more water or not. And they have to set it up, they have to upload it, they have to learn, and also afterwards test the whole system whether it works with out of sample data as well. And finally, we talk about ethics again, as we said before. In some cases, especially if you work with human data, it's important that you understand that artificial intelligence can have certain kind of drawbacks when it comes to decision making, and we just want to make sure students understand those issues and have those ethics problems in mind when they work with artificial intelligence. This is just an example how this all looks like. We have this teachable machine. We have different images, for instance, images where moors are too dry or too wet. We will have this training set. You have a training model, and you can also export this model afterwards and try to figure out whether it works with unseen data as well. It's very easy to use. You don't really need a lot of coding or anything. And we also had some sort of a software for the breakout sessions, for instance, Moodle. Obviously, this is required as well. So what did we get? As I said before, we have done this workshop in class before. Now we've been doing this workshop online, and we wanted to see whether there are big differences. And I told you before, we have been measuring those constructive dimensions. It was just a questionnaire, a standard questionnaire. You have standard questions to measure that. And we used that data in order to compare the online version with the classroom version. Interestingly, by and large, there are not a lot of huge differences. You see it, for instance, on the constructive side. It just appears on the graph, at least, that there is a little bit of a difference between classroom-based workshops and our online workshop. However, by and large, there is not too much of a difference. What you would usually expect, that there might be a huge difference in the social dimension, that it's much more difficult online than in class. However, as you can see here, there are not too many differences. So what did we basically find? We would generally think that we get fairly high values. I mean, it was a Likert scale from 1 to 5. For most of the dimensions, we get fairly high values. So we would conclude that by and large, our workshops work fairly well. When it comes to the comparison between the physical one and the online one, there are certain kind of areas where it seems that the physical ones are doing a little bit better, but by and large, we don't really see too many problems. I must say we had fairly small groups. This was one of our drawbacks. So it was difficult to do statistical tests. Basically, the statistical tests would tell you that there are no differences, but as I said before, as the sample was fairly small, it doesn't really make sense to have a statistical test seeing whether there are statistical differences, just the sample is small. And we also found that, I mean, this is basically the feedback we got from our students, that the reflection work is very important so that they can, after the task, reflect and talk to each other to see what the problems within other groups have been, and just learn by experience, basically, and also experience by others. So what are our conclusions? Workshop-based hands-on introduction to artificial intelligence seems to be workshops that worked out fairly well. The initial experiments have also shown that students show comparable results to the physical workshop. As I said, we can't really give any statistical numbers here because the sample is too small. However, for that reason, we definitely have to get a larger sample and see whether we also find this on a statistical basis, that there are not too many problems. And we also plan to further deepen the workshop by also using Python. I mean, we use Python then in class later on, but it might be good to already start with Python in the workshop. But it's usually involves well a certain level of coding knowledge, which might be complicated as well. Okay, so thank you very much for your attention, and if you have any questions, please let me know.